Hi, in this tutorial we will learn how to create these parametric bookshelves. At the end you will be able to adjust and control all the parameters. For example, I can change the overall size of the wall and the bookshelves. I can control the size of the bookshelf separately. Also, you will be able to control the scale in the 3 directions separately. You will be able to control the number of shelves in both directions. You can control this small offset here. And of course, you can control the thickness of the shelves. So we will start from scratch. Okay, first I'm working in small object centimeters. I will create the vertical wall, plane surface, XZ plane to make it vertical. Now for the size, I will choose 400 centimeters. I will calculate the centroid of this plane using the area component. I will use this point here to create the sphere. So I will bring a sphere for the radius. I will make it. I will create a relation between the size of the wall and the sphere radius. From math, I will bring the divide 2. Now by dividing this number to 2, if I connect this to the radius, I will be creating a sphere that has a diameter that equals the length and width of this wall. Now, to be able to control the radius separately from the size of the wall, because now if I change the size of the wall, the size of the sphere will go with it. So I will bring a subtraction component. And I will put a slider here from 0 to, let's say, to 100. And I will connect this to the radius. Now at 0, nothing will change, but now when I increase this number, the sphere will decrease in size. So now what I should do is to slice this sphere using this thin wall here, because I only need this part here. So from intersect menu, shape, B-wrap split, this will allow me to split one B-wrap with another one. So I want to split this sphere, and this will be the cutter. The output here are two objects, the two parts. I only need one, so I will use a list item. And by default, the index is 0, and 0 is the one that I want. I can hide this. Okay, so here I have this base sphere. I will group all of these, Control G. I will add scribble here, scribble component, just a text. I will call it base sphere. I can add it to the group here. Okay, now the next step, I want to be able to increase or decrease the size of this sphere in three directions: in the horizontal direction, in the vertical direction, also in this direction, the depth. So I will bring a scale non-uniform, which is this one, scale non-uniform. This will allow me to scale in three directions separately. So I want to scale this. The plane, the center of this operation will be the centroid. So I will connect this centroid to the plane. I can hide this now. And I will add three sliders from 0.01. I don't want it to be a 0, so I will make it 0.01 as a minimum, and the maximum I can leave it at 1, full scale. So now I can manipulate the X direction, the Y, the depth, and the vertical diameter. Now, what I will do is to use a bounding box that goes around this sphere here. The benefit of bounding box is that it will adjust whenever I increase or decrease the size of this sphere. It will adapt. And why do I need this bounding box? Because I want to extract the vertices and calculate the distance between this vertex and this vertex to get the horizontal diameter, and this at each moment. So this number, this distance will change when I increase or decrease the size of this sphere. Also, I want the distance between this vertex and this vertex for the vertical diameter. I will need these numbers because later on I will divide these numbers with the number of shelves I want to get the distance between each shelf. So now I have this bounding box. I will explode it from surface, deconstruct B-wrap. Okay, so now I want to calculate the distance between this vertex and this vertex. I need to get the indices of these two vertices. So I'll bring list item now at index 0 I get this one. So I need to know the index of this vertex. I will bring a slider from 0 to 7 because I have 8 vertices. Click this list item and then try to move the slider. So this is 1. So okay, so I'll bring this back to 0 and I will make a copy from this and a copy from this. And I will make this one 1. So I have these two vertices. Now I can bring a distance component. And this will give me the distance between those two vertices. So I will group these and bring a scribble and call it horizontal diameter. Now another list item. Okay, this is 0. I want this vertex here. Again, a slider from 0 to 7, just to check the index of this point here. So this is 4. So I'll bring back this to 0. By the way, when you drag a component, while you are dragging, you can click Alt to make a copy from it, if you don't know this by now. So I will make this 4. So now I have these 2 points. Again, I will make a copy from distance. I will connect those two here. And I will group these, make a copy, and call it vertical diameter. Okay, now I will bring a contour component. I will plug the sphere. I will create the vertical shelves first. So the direction of this contour will be the X direction. The distance between each contour. Now here I will use this distance thing. I will go to Math, divide. I will divide this horizontal diameter with the number from 1 to, let's say, 30 for now. Plug it to distance. Now, as you can see, it's not symmetrical. So I will connect the centroid to the point input. This will make it symmetrical. I will hide the sphere. Now for these, I want to close these shapes here to be able to extrude them. So I will use close curve component. Will hide this. Now I have a closed shapes. As you can see from these dashed here that Grasshopper created a sub lists, each sub list with one curve. I don't need this kind of complex data structure, so I will right click and flatten this. So all of them are in the same group. So now what I should do, I want to extrude these. So I will use extrude. Now the extrusion should be in the X direction. So choose a number, let's say 2 for now. I want also to extrude them in the opposite direction. So I will Control C, Control V. But here I would right click, expression, and put -X. So if I have this number 2 here, I'm creating a thickness of 4. So if you like, you can reduce this to, let's say, 1.5. And those two, I will join them with brep join to make them one object. And I will close with cap holes. Now I will do this process for the other shelves. Now I will copy all of these, Control C, Control V. Here instead of X unit, I have to choose the Y unit. For direction here, I will choose Z direction. For the extrusion, here I made a mistake. It should be Z direction, sorry. So now I should give some thickness to this wall. So I will choose extrude. Direction Y. before I continue, there's a missing step here. For these here, I want to offset them. So here, contour closed. Before closing the contours, I will do something else. I will offset these curves here first, then I will close them. So offset curves. For the distance, I will choose, say, from 0, 1 to 20. This way I can offset these. Okay, now I can give some colors to these shelves. Swatch. Also, I can give a color to the wall. Okay, now that's it, and as you can see now I can change the overall size of this. I can play with the size of the sphere separately. I can change the size in the horizontal direction and the vertical direction. I can decide the number of shelves in the vertical direction and in the horizontal direction. I can play with the with this offset here. I can also play with the thickness. Now I can choose the same number here for the both thicknesses because, you know, and that's it for this tutorial. Hope you like it, and if you do, please press the like button and subscribe to the channel, and see you in the next video. Thank you.